Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope you are doing well. Lecture for grade 10, subject chemistry, chapter number 11. Today we will do the think tank of this chapter, and also we will start chapter number 12 and we will do introduction. This is my 16th lecture, and here is your lecturer, Mrs. Saira Jamal. Dear students, today we will do the think tank of chapter number 11. Question number 12 of think tank is given a molecular formula of a compound containing carbon, hydrogen and oxygen and single bonds. List all the possible functional groups this compound can have. So alcohols are characterized by the presence of the hydroxyl group. Alcohols contain carbon, hydrogen and oxygen, and the OH group, which is called the hydroxyl group, it is attached to the carbon atom through single bond. You can see here in this case OH group is attached with the methyl group through single covalent bond, and it is called methyl alcohol, which is the common name, and IUPAC name is methanol. Meth for one carbon atom I told you, and the E of alkane is replaced by OL, so this is the name of this compound is methanol. In the second example, we have two carbon atoms, so eth for two carbon atoms. So E of ethane is replaced by OL. So the name of this compound is ethanol, that is the IUPAC name, and ethyl alcohol is the common name. General formulas for alcohol is ROH. R is any alkyl group, maybe one carbon containing, two carbon containing, three carbon containing, so on and so forth. It varies, but the functional group will remain same, that is the OH or the hydroxyl group. So ROH is the general formula for alcohols. Second compound which also contain carbon, hydrogen and oxygen and all the bonds are single is ether. So what are ethers? Organic compounds that have two alkyl groups attached to the same oxygen atom are called ethers. These compounds have general formula ROR. R I told you are the alkyl groups and they are attached with the oxygen. So the two R groups or the two alkyl groups may be same or they may be different. For example, in this case, you can see the two alkyl groups are same. So the name of this compound will be dimethyl ether. While in this case, at the left side, methyl group is attached, alkyl group is a methyl group, and at the right side, the alkyl group is the ethyl group, eth for two carbon atoms, so ethyl group. The name of this compound will be ethyl methyl ether because you will follow the alphabetical order. E comes first or E comes before then M. So we will name it ethyl, then M, methyl and ether. In this case, both the alkyl groups are same, so dimethyl ether is the example. So alcohol and ether are the functional groups or the organic compound which contain carbon, hydrogen and oxygen, and all the bonds are single bonds. Question number 30. Give the condensed structural formulas of the following compounds and classify each on basis of functional group. You can see in this case, this chain is alkyl group and it contains three carbon atoms. So we will use the term prop for three carbon atoms, and as OH or hydroxyl group is attached with this alkyl group. So this compound is alcohol and the name of this compound will be propanol. Propane, E of the propane is replaced by the alcoholic functional group, that is OL. So as the OH group is attached with the carbon number 1, so the name of this compound will be 1-propanol. Condensed structure formula, we will follow the same pattern. The first one, the carbon which is attached with the hydroxyl group, two hydrogen atoms are attached with it. So we will write OH with CH2. The next carbon also has two hydrogen atoms CH2, and the last one has three hydrogen atoms CH3. So the name of this compound will be 1-propanol, and the functional group is alcohol because ROH, which is the general formula of alcohol, So this is an alcoholic compound, or this compound contains alcoholic functional group. Second example, you can see oxygen is present at the center and the two alkyl groups are present at the two sides. So this is CH3 at right hand side and CH3 or alkyl group or methyl group at the left hand side. So you can see the general formula of ether is ROR, and the name of this compound is as two methyl groups are attached with oxygen. So this is dimethyl ether, and the functional group is ether. Question number 14, the diagram represents an organic compound that contains three different elements. Those three different elements are X, Y, and Z. So what could be the compound? Suppose we know that the hydrogen always comes at the side in case of the hydrocarbon. So this means that X are hydrogen atoms, and in the center always carbons are present. So why because each carbon is making a four bonds. So you can see that this Y is making four bonds, one at the left hand side, one bond at the right hand side, one bond up and one down. So total four bond. It means that this element is carbon because it is making four bonds. And these elements are present at a side and they are making single bond. So this element will be hydrogen atom. Then Z is different and it is attached with carbon as well as with hydrogen. So hydrogen is attached with the oxygen atom. So Z is or Z is oxygen atom. So what could be the compound? Is this compound be ethanoic acid? No, for ethanoic acid we need the with the hydroxyl group we need the carbonyl carbon atom. So there is no carbonyl carbon here. For propene we need double bond. There is no double bond. For ethanol, we need OH group. So yes, it is ethanol. And for propane, we need all the atoms. They must be same like hydrogen. No oxygen over here. So the correct name of this compound is ethanol. Ethanol. Option C is correct. Polyvinyl chloride (PVC) is a polymer and it is used for making vinyl sheets, drainage pipes, wire insulation to make the electrical wires insulated. So the coating on that wire is of polyvinyl chloride. It is obtained from vinyl chloride. This is the formula of vinyl chloride, means it is an alkene, that is an you can see it is an ethene which has carbon double bond carbon atom. So classify vinyl chloride as saturated or unsaturated compound. So what do you think? As carbon-carbon has double bond, so it's understood that all the alkenes, they contain carbon-carbon double bond, and alkenes and alkynes are unsaturated hydrocarbon. So vinyl chloride is an unsaturated compound because it contains carbon-carbon double bond. Question number 16, for each of the following, draw the structure formulas of a two carbon compound containing the indicated functional group. So in all, for all the cases, we will use only two carbon containing alkyl group. So two carbon containing alkyl group is ethyl, and for alcohol, OH is the functional group attached with the alkyl group. So ethanol, this compound is ethanol or ethyl alcohol. Second one for aldehyde. For aldehyde, we will use only two carbon containing aldehyde. So you can see CH3CHO, or we can also write it in structural form CH3 C double bond O and H. So this is I told you that while naming aldehyde, E of the ethane is replaced by Al. So the name of the compound will be ethanol. Ethanol from ethane, ethanol, and common name is acetaldehyde. Common name of this ethanol is acetaldehyde. Carboxylic acid needs carbon double bond oxygen with OH, means two functional groups are present, carbonyl as well as hydroxyl. This is called as, and we can also write this carboxylic functional group as COOH, and it is called acetic acid. And IUPAC name for two carbon containing acid is ethanoic acid. Alkene, two carbon atoms having carbon-carbon double bond, and as there are two carbon atoms, so ethene, eth from and N of the alkane is replaced by ene. So ethene is the name of this compound. Question number 17. Aspirin is a mild painkiller and fever reducer. It is manufactured from salicylic acid. This is the structural formula of salicylic acid. You have to identify the functional group present in it and encircle them. So the functional group is this one, carboxylic group. So you can encircle this carboxylic group, and also we have another functional group, that is the hydroxyl group is there, two, and the third one is the carbonyl group, C double bond O. This C double bond O, which is the carbonyl group, is also present there. So there are three functional groups in this case. Here I mentioned two, but the third one is hydroxyl functional group, this one as well. So one, carbonyl group 2, and complete carboxyl group 3. Number 18, general formula for alkane is CnH2n plus 2. What will be the general formula for alkyl radical? I told you alkyl radicals are one hydrogen less than alkane. So if there are two hydrogen atoms, here you have to write one hydrogen atom. So CnH2n plus 1 is the general formula for alkyl radical. Question number 19, water adds to ethene. You can see in this reaction, this is ethene, and water when react with ethene, it will give ethanol. You can see CH3, CH2OH. So identify functional group in the reactant and product molecule. So reactant has carbon-carbon double bond, it is alkene, and product has alkyl group attached with OH, which is alcohol. So functional group in the product is alcohol, and functional group in the reactant is alkene. Question number 20, bonding of carbon atom to heteroatom. Heteroatom means an atom other than carbon atom. If carbon is making bond with oxygen atom, or if it is making bond with nitrogen or with chlorine, so like atoms other than carbon, so that is called heteroatom, increases the number of organic compounds justify it. All heteroatoms have a greater or lesser attraction for electrons than does carbon, or does each bond between a carbon and heteroatom is polar. If carbon is making a bond with oxygen, so there is a greater electronegativity difference between carbon and oxygen, and due to that greater electronegativity difference, we can say the bond of carbon with the heteroatom is polar. The most important atomic grouping that contain such reactive polar bonds are also able to generate functional group. Therefore, bonding of carbon atom to heteroatom increases the number of organic compounds. So we have many functional groups, and then they have families. So there are, you can say, millions of organic compounds present in our surrounding. And one of the property is of the carbon, that it can make bonds with heteroatoms or with atom other than carbon atoms. Let us start the chapter number 12, that is about the hydrocarbons. What is meant by a hydrocarbon? A hydrocarbon is an organic chemical compound composed exclusively of hydrogen and carbon atoms. So hydrocarbons contain carbon and hydrogen only. Hydrocarbons are naturally occurring compounds and form the basis of crude oil. They are present in oil, in natural gas, in coal, and other important energy sources. All of these energy sources contain hydrocarbons. and they are naturally occurring compounds. Millions of organic compounds are present in our surrounding, and to understand how will we recognize them, how will we classify them, how will we learn their name. So systematic naming of this compound is necessary to recognize those millions of compounds and to learn their names. So organic chemists began in the last century to devise a system of naming organic compounds, and that system depend on their structure. An international body or an international system, which is called the International Union of Pure and Applied Chemistry, abbreviated as IUPAC, pronounced as IUPAC system, constantly reviews the rules. IUPAC system reviews some rules for naming organic compounds, and this system is accepted all over the world, and the IUPAC names are used all over the world. So IUPAC system of naming organic compound is based on some principle and on some rules. Each different organic compound should have a different name. So they have different name, but their functional group is same. So they are present in a same family, or they are related to a same family. For example, alcohols, all the alcohols have OH functional group, but their name varies on the basis of the number of carbon atom. For one carbon containing alcohol, methanol; for two carbon containing ethanol, then propanol, then butanol, so on and so forth. So it varies, and due to this property, it is easy for us to identify an organic compound, or to recognize an organic compound, and to judge about its properties. It's very easy because of this special system, which is called IOPAC system. Society, technology, and science. It is about the importance of alkenes, polymers. And polymers, you know that smaller units combine together to form larger molecules, which are called polymers. And the phenomena is called polymerization. So alkenes also combine together, as I told you in case of the polyvinyl chloride, where vinyl groups or alkene groups, they combine together and form polyvinyl chloride, and that polyvinyl chloride is used as a polymer in making different substances. So alkenes are starting material for the synthesis of many valuable materials, especially polymers. Some alkenes and alkynes, alkenes double bonded carbon containing compound, and alkynes are the triple bonded carbon containing compound, serve as starting material to synthesis. For instance, ethene and ethine are used to synthesize a number of polymers, not only polyvinyl chloride, but they also make other polymers as well. Polymers are made from smaller molecules such as ethene, and then they'll combine together to form polyethylene or polyethylene, which are the plastic bags which we are using on daily basis. So polythene bags or plastic bags, they are made up of ethyl. Polymers are made from smaller molecules such as ethene. Look around you, you will find polymers everywhere. Your clothes, carpets, curtains, towels, sheets, floor tiles, furniture, toys, etc. are polymers, and they are made up of ethene and ethyne, means alkenes and alkyne, because ethene and ethyne are the examples of alkenes and alkyne. Even in your car, the dashboard, seats, tires, floor mats, ceiling, all are polymers, and they are made up of ethene and ethyl. Hydrocarbons are also used as a raw material for the synthesis of synthetic rubber, plastics, films, adhesives, drugs, and dyes. So in the field of medicine, even the body replacement parts, which are made up of polymers like artificial legs, artificial hands, they are made up of polymers, and it means that polymers, we can also use polymers in the field of medicines as well. In the future, we will have artificial bones that can stimulate bone growth. We can also to expect have artificial lungs as well as artificial hearts, industries are day and night busy in synthesizing marvelous new products. They are trying, they are like these are under study to make these artificial heart, lungs, and the other body parts. In future, they are trying, and it is under discovery. You can see in this image the products which are made up of ethylene. Ethylene, I told you, carbon-carbon double bond compound, which is also called ethene. Ethene or ethylene is used to make cosmetics, to produce the rubber, which is the synthetic rubber, and in also we can use it in pharmaceutical industries, in making electronics, in making textiles products, even paints, and I told you the polythene bags and like the diapers, children toys, agricultural products. Like we can use it as an artificial ripener of food. So we can also use it in agriculture as well. And also for the treatment of wood, we are using ethylene. So all these are the important uses of products made up of ethylene or ethene, which is an example of alkene. Acetylene or ethane is used in cutting and welding of metals because it has the oxyacetylene flame is very hot. It has a very high temperature, and we can use that oxyacetylene flame in for cutting and welding of the metals. Types of hydrocarbons, we have two important types of hydrocarbons, aliphatic hydrocarbons and aromatic hydrocarbons. Aliphatic hydrocarbons are actually those type of hydrocarbons which are further subdivided into alkanes, alkenes, alkynes, and also cycloalkanes. While aromatic hydrocarbons, they contain at least one benzene ring in their structure. Let us discuss these types of hydrocarbons one by one. The first type of hydrocarbon is alkanes. What are alkanes? Alkanes are saturated hydrocarbons. They have general formula CnH2n plus 2. Each carbon atom forms 4 bonds. You know, carbon is present in group number 4 and it has 4 electrons in the outermost shell, and in order to complete its octet, carbon needs 4 more electrons. That's why carbon is making 4 bonds, and each hydrogen atom from only 1 bond because hydrogen has only 1 electron in outermost shell, and in order to complete its duplet it will use only 1 electron. So the simplest alkane molecule that is possible is methane, because definitely we'll start from 1 carbon atom and then the number of carbon atom will exceed it from methane to ethane, propane, butane, pentane, so on and so forth. But the simplest one or the smallest alkane is methane. It is called methane. Methane is the main component of natural gas, and we learned it before that the highest percentage of natural gas is methane. And in addition to methane, natural gas also contain ethane and propane and butane as well. But the highest percentage in natural gas is the methane gas. Electron dot and cross structure for methane. The electrons of carbon we will mention by putting 4 dots. Like you can see, there are 4 dots in the surrounding of carbon atom, and these crosses are the electrons of the 4 hydrogen atoms. So you can see that this structure is called electron dot and cross structure, by which we will mention the electrons which are shared between the atoms. We will mention them by electron dots and cross. Structure formula for methane is carbon is in the center and there are single covalent bond, because if they'll share one electron, and in other words, we can say that the bond which is formed by sharing 1 electron pair is called single covalent bond. So you can see all these 4 bonds are single covalent bonds, and the single covalent bonds we can mention by putting solid line between the two atoms. So this is C having 4 hydrogen atoms in surrounding is called the structure formula for methane. The next number of alkane series is ethane, which contains 2 carbon atoms, and ethane molecule has the following structure. You can see CH3, CH3 for ethane. All the bonds are single covalent bonds, and each carbon is making 4 bonds. You can see each carbon is making 4 bonds. Example 12.1, writing structure formula for an alkane. If you want to write a structure formula of an alkane, suppose for propane. So what will you do? Prop means 3 carbon atoms, and it means you will first make 3 carbon atoms, and all the, because it's from the name indicated propane or alkane means all the bonds will be carbon carbon single bonds. So you can see the 3 carbon atoms are making single covalent bonds. And then while naming this compound, the E of like alkane, we will write A and E and while naming alkane. So prop means the 3 carbon atoms and all the bonds are a single covalent bond. So we will use the name propane and for alkane and prop for 3 carbon atoms. The name of this compound is propane. Prop for 3 and N as all the bonds are single covalent bond. It is saturated hydrocarbon and it is a stable alkane. Self-assessment exercise 12.1, write structure formulas for butane and pentane. So but means 4 carbon atoms and N means all the bonds will be single bonds. So you can see 1, 2, 3 and 4 carbon atoms, and then definitely the hydrogen atom will be completed by making 4 bonds of each carbon atom. So this is the structure of butane. And for pentane, 1, 2, 3, 4, 5, we need 5 carbon atoms, and then valency of carbon atom is completed by making 4 bonds of each carbon atom. So you can see three hydrogen are present at the terminals, while two hydrogen atoms are present at the on the middle carbon atoms. Example 12.1, draw the electron dot and cross structure for ethane. Ethane have 2 carbon atoms and the electrons of carbon, I told you, we will mention them by dots, and the electrons of hydrogen we will mention them by crosses. So you can see 1, 2, 3, 4, 4 electrons of this carbon atom, 1, 2, 3, 4, 4 electrons of this carbon atom, and they are making 3 bonds with 3 hydrogen atom because 1 bond is between the 2 carbon atom. So this is the electron dot and cross structure of ethane. Self-assessment exercise 12.1, draw electron dot and cross structure for the propane and for butane. So for propane, we need 3 carbon atoms, 1, 2, 3, and electrons of the carbon atoms, I told you, will mention them by dots, while those of the hydrogen atom we mentioned by crosses. So this is electron dot and cross structure for propane. Same for butane, 1, 2, 3, 4. We will use 4 carbon atoms. So 4 carbon atoms are present for the butane, and all the bonds will be single. So single covalent bond is formed by the mutual sharing of electrons of one pair of electrons between 2 atoms is called single covalent bond. So these type of alkane, because I told you they are saturated, all the bonds will be single and they are making bond. So dear students, I hope you will understand this lecture, and inshallah we will continue chapter number 12 in our next lecture. Till then, take care. Allah Hafiz.